Hello everyone, welcome to Solutomatic, where you will learn how to solve logical math problems. The concept for today is counting the number of selections. You will be given a certain number of objects and also will be given a number of conditions. You will have to select a few objects from all the objects given, following all the conditions. So let's get started with our problem. Our problem reads, 3 pandas are traveling to Hawaii for a vacation. On their flight, an argument arises. Upon reaching their destination, they decide they don't want their rooms next to one another's. When they arrive at their hotel, they have the option to choose from 7 rooms. What is the total number of different ways they can choose a room? Sorry, I mean 3 rooms. In this problem, the rooms are our objects. So basically, we have 7 objects to select from. So, how many objects do we have to choose? 3. 3 for the 3 pandas. And now, what is our condition? Our condition is that none of the rooms that are selected can be next to each other. Alright, so I hope the problem is clear by now. So now, let's see how we can solve it. So, let's try to solve it using a table. Remember, in this problem, we're not looking for which panda gets which room. Instead, in this problem, we're trying to see in how many ways 3 rooms can be selected. So, here is our table we will use to solve this problem. Before we begin, let's briefly discuss our strategy. We will first select our first room, and then we're going to see in how many ways the second and third rooms can be selected. So now, to our graph, let's choose room 1 as our first room. Oops. There. So now, let's look at what the second selection for the second room can be. So, we cannot select room 2 because our condition is 2 rooms cannot be next to each other. So, let's put room 3. Now, we have selected our first room and our second room, and we have yet to select our third room. What are the possible rooms that we can select for our third selection? It cannot be room number 4 because of our condition. The possibilities for our third room is room 5, 6, and 7. Our first possibility is room 5, then in the next one room 6, and then room 7. So these 3 rooms are the possibilities, while the first selection is room 1 and the second selection is room 2. Sorry, room 3. So now, we will keep our first selection room 1, but our second selection will now be room 4. So room 1, room 4. So now that we have those 2 rooms selected, we think, what are the possible selections for the third room? So, the only possibilities for the third selection is room 6 or room 7. That's room 6, room 7. Now, again, let's keep our selection 1 to room number 1. But now, let's change our second selection to room number 5. So now, what are the possible ways that we can select our third room? One might think that room 3 can be selected as the third room. That perfectly follows our condition. But if we do that, that turns out to be a replica of sorts of the first row. Room 1, room 1, room 5, room 5. They're diagonal, but still. Room 3, room 3. So room 3 cannot be selected as our third room. So, because of that, the only possible selection for the third selection would be room 7. So, these are all our possibilities when the first selection we have is room number 1. Now, let's see what are our possibilities when our first selection is room number 2. When our first option is room number 2, our second option can be room number 4. So now, we can either choose room number 6 or room number 7 for our third choice. First, we keep our first choice to room number 2. Then, we choose our second room, which cannot be 4 because we already have 4, which is room number 5. After we have these two selections, the only possible third selection is room number 7. That's all we can choose when our first selection is room number 2. Now, let's change our first selection to room number 3. So now with our first selection, room number 3, the only possibility for the second selection is room number 5, R5, and then third selection, room number 7. We do not have any other choice that is a valid duplicates. So now, let's see what happens when we choose our first selection as room number 4. In this case, when our first selection is room number 4, our second selection will have to be room number 6, and our third selection will have to be room number 8. Wait, there is no room number 8, so this is not a possibility. So, there is no other valid selection left, which is not a duplicate. So now we have found out all of the possible selections. So our answer for this question is the number of rows in this table, which is 10. So we have 10 different ways of choosing 3 rooms. So we have solved the problem of selection of 3 rooms. So what happens if we want to solve this follow-up question? Our follow-up question reads, in the same hotel, how many different ways can the 3 pandas occupy a room each, given the same condition that they don't want to stay next to each other? We will briefly discuss the solution of this question when I come back with my next video. I hope all of you have enjoyed this video, and if you did so, please don't forget to subscribe to my channel and like this video. Bye! See you in the next video.